Hey everyone, got a video for you today to check your homework. Should be quick. Just want to run through and describe some of the choices and decisions I made and why. So these notes are posted online, so you can just read through them yourself if you just want to check your answers and don't need a lot of explanation. But otherwise, here we go. So for number 13, for 13 through 15, actually, you're just pretty much writing down the trigonometric ratios. So sine, cosine, tangent. All the triangles are drawn for you in the book. I didn't draw all of them, but you can just look back on the pages to double check. Sine is opposite over hypotenuse, so 2 over 6. And then remember, you have to simplify. Always check for simplification, right? So 1/3 final answer there, cosine. So you can simplify also. There's your answer. And then tangent, you get one of the situations where you have to get the square root out of the denominator. So you just multiply it through. You can see my work there, and then final answers there. Same thing for 14 and 15. I'll let you look through those. Nothing crazy to mention here. Most of these are pretty straightforward. They all have to be simplified though, for the most part. So just make sure you're doing those correctly. And then if we move on to 16 through 18, I think, are all pretty similar. They're all special triangles, the ones we talked about, the 45, 90, and 30, 60, 90. So what you do here, right, is you compare the two things we know. Remember, the special triangles are basically like the basic form of what that triangle could be. So in number 16, we have a 45, 45, 90. And we know that from the 45, 45, 90 triangle, that the cosine of 45 is the square root of 2 over 2. And that's just from the notes. It's from the book. That's just always true. Okay, so that's if you have a small like length of one triangle, the cosine of 45 is square root of 2 over 2. From this triangle, right, we know that sorry, I'm getting a phone call. We know that we look at this triangle, right, this one in the drawing, and what we don't know is x. X in relation to 45 is adjacent to it, right? So that tells you right away that we're going to have to use either cosine or tangent. The other side we know is 150. That happens to be the hypotenuse, so this is going to involve cosine, right? So that's why we chose the cosine at the beginning. This triangle says cosine 45 is going to be x over 150. And now I have two things to set equal to each other, okay? And then you just set those equal to each other, and then the math is right here. It's just a ratio. That means x is 75 square root of 2. So if you need more explanation or help with how that works, just let me know. But it really is just about setting, using what you know about special right triangles to set ratios equal to each other. For 30, 60, 90, it's the same idea. It's just about figuring out which ones you need, right? In this drawing here, we have a degree of 30. The side we know is 70, which is opposite from it. So it kind of tells you what we need to use. And then x happens to be a hypotenuse. So opposite and hypotenuse involve sine. We know from the special right triangles that sine of 30 is 1/2. And we know from this triangle that the sine of 30 is going to be 70 over x. Again, set those two equal to each other. X is 140. For the last one, the angle we're using is 60. If you look at the triangle, the sides that we're dealing with are the opposite side, which is x here, right? Let me zoom in a little bit. X is the opposite side. 10 is the hypotenuse. Again, it's opposite and hypotenuse, which is sine. Sine of 60 from the special right triangle is square root of 3 over 2. Sine of 60 from this triangle is x over 10. We set them equal to each other. X is going to be 5 square root of 3. Pretty simple, hopefully. Once you set them equal to each other, the algebra is simple. This part up here is hard, right? But just try to recognize like the what you have to use and why. And then once you get to this math part, it's not that bad, right? It's just getting to this, like when you set them equal to each other, that's getting there is the challenge. All right. The word problem is just takes a little bit of, you definitely want to draw to help you if you like that. Um, so what, here's the drawing they gave you, right? There are two unknowns that you need to figure out, are the regular height of the pyramid and the slant height, right? The length of like the slant of the pyramid. And they tell you that the degrees that we're dealing with are 52 degrees, right, on each corner, which helps. And why they have this dotted line here with the right angle is, that's the most helpful part, right? Because that creates the right triangle. So I wrote here, it makes a right triangle if we split it in half, and that's what I drew here is half of the pyramid, which is really helpful because now we have a sine 52, and the sides that we have are the height, the slant height, and then if you take the base and divide it by half, you get 115, right? And now that's all we need to set this up, because you just pick whichever of the three functions to find the unknown. If we want to solve for height first, which is part A, well, height is a cross or opposite of 52, and then of course we have to use the 115 because that's the only number we know. We only want one unknown, right, at a time. So h is opposite, 115 is adjacent. Opposite and adjacent are tangent. So you set up here, tangent of 52 is going to be that h over 115. Just use your calculator. That means that the height is equal to 115 times tangent 52. And then you get approximately, you just round to the whole number, you get approximately 147. Now for B, to figure out the slant height, you have to use a different function, of course. We want the hypotenuse. I just used the 115 again, but since you figured out h, you could use that. But I just said, okay, well, I know 115, which is adjacent to 52. Adjacent and hypotenuse is cosine. So cosine 52 equals 115 over the slant height. That means the slant height is going to equal, you just switch it around a little bit. 115 over cosine 52, use your calculator, it's approximately 187. So yeah, let me know if you need extra explanation with that. I'll try my best to help. I can also make a separate video just explaining special right triangles